Okay, we want to figure out the length or the distance of the perpendicular from a point to the plane. Let's say we have a plane. Let's use the equation of the plane, and we have a point A outside the plane. Its position vector is A. Now, equation in normal form would be what? R n divided by magnitude of n, q by magnitude of n. So what this would become is vector n divided by its magnitude will leave us with the direction only. So n cap is equal to q by magnitude of n. Okay, let's very quickly draw a diagram. We have a plane. So let's say we have this plane. We have a point, let's say A outside the plane. What we want to figure out is the distance between the plane and A. Let's look at the origin. Let's say the origin is here. The position vector of this point would be A. Now the distance of this plane from the origin would be, and we know this, we have already done the derivations. So let's say this is n, perpendicular length or distance from origin would be ON, which is magnitude of n. Now, equation of the plane through a point, so in this case A, and parallel to the given plane, that is, so here what are we talking of? We are talking of another plane which is parallel to this plane and passing through point A. Another plane which is parallel to the given plane. Now for this also we know the equation. So R minus A dot n equal to 0. If you don't remember, please go through the previous videos. Now this implies, let's do the opening the brackets, A n equal to 0, which means Rn equal to An. So we have a plane now. Now we figure out the distance of, or perpendicular distance of this new plane from the origin. Let's say this is n prime. Now length of the perpendicular On prime from origin to the second plane, let's say plane 2. Okay, now let's, in the diagram also, let's mark it. Let's say this is plane 1 and this is plane 2. So we want to figure out the perpendicular distance of plane 2 from the origin. So On prime is equal to An divided by magnitude of n. So now we know the perpendicular distance from origin to the plane 1. We know the distance between the origin and the plane 2. That means if we subtract it, we get the distance between these two planes. Now, if we get the distance between these two planes, we know the distance between A and M, between the point A and the first plane. So perpendicular distance between plane 1 and plane 2 is equal to the perpendicular distance of the point A from plane 1. So AM is equal to ON minus ON prime, which would be equal to, now ON we know is Q by magnitude of N minus AN divided by N. So which means Q minus AN divided by magnitude of N. And to make sure that it always comes out positive, because we are talking of distance which has to be positive, let's take the magnitude of the entire thing. So this is the equation for figuring out the distance between a plane and a point not on the plane. Now let's look at the same thing in Cartesian form. Now here, let's say the plane is ax plus by plus cz plus d equal to 0. Okay, now we have a point A outside the plane. So let's say its coordinates are x1, y1, z1. Let's say the vector r is xi plus yj plus zk. The normal vector normal to the plane, we can use the direction ratios. So ai plus bj plus ck. Now q would be equal to minus d, and let's say the position vector of A is x1, y1, z1. So now let's vector n is equal to minus d. Okay, now we already know the perpendicular distance. The equation is q minus a n divided by magnitude of n. So let's do the substitutions. Q is minus d minus a dot n. A is, so x1i plus y1j plus z1k dot, normal is n is ai cap plus bj cap plus ck cap divided by magnitude. Magnitude is of n is a square plus b square plus c square. Now minus d minus ax plus by1 plus cz1 divided by a square plus b square plus c square. So minus d plus ax1 plus by1 plus cz1 divided by a square plus b square plus c square, which is equal to, this c minus can disappear now, but still we retain it to ensure that again negative doesn't appear. So ax1 plus by1 plus cz plus d divided by square root of a square plus b square plus c square. So this is the perpendicular distance from a point outside the plane in Cartesian form. Okay, now there are a few points. The perpendicular distance is positive if the point lies on the same side of the plane as the origin, and naturally which means negative if on the other side away from the origin. So that means we have a plane, this is the origin, the point from which we want the perpendicular distance could be here or it could be here. if it is on the same side as the origin, or it could be, so this would be positive and this would be negative. Now the other point is points A and B lie, suppose we are talking of 2 points on the same side, if distances are of same sign. So basically, let's say this is A, this is A prime. Let's say we have another point here, B and B prime. So here what it means is that A and B, they both are lying on the same side. And remember, both of them will be negative. So they are of same signs. So which means that they are on the opposite side of the plane with respect to the origin. Okay, here they both will be positive. That means the signs are same because they are on the same side as the origin. Okay. Now if we compare A and B prime, then they are on the opposite sides. So one of them will be positive, one of them will be. I think you got the idea. Enough for today. Bye for now.